In the previous section, stability, we saw the three axes of the aircraft: longitudinal, lateral, and normal. Now we're going to take a look at control to see how the pilot maneuvers the aircraft about these axes.
In most cases, roll, yaw, and pitch are obtained by using simple flap-type trailing edge surfaces. Ailerons, rudder, and elevators. Most aircraft have 5 principal aerofoil surfaces: port and starboard wings, port and starboard tailplanes, and fin. Each aerofoil has a control surface.
Now let's see what each of these control surfaces does. First, ailerons. Lateral control about the longitudinal axis.
The primary effect of ailerons is to roll. One aileron moves up, the other moves down, producing a difference in the lift force of the two wings.
Now let's take a closer look at what happens when the ailerons are operated.
We saw earlier that lift and drag depended on aerofoil-shaped camber and angle of attack. This one is at 0 angle of attack. It's producing a certain amount of lift. Now, if, without altering the angle, we have a hinged trailing edge, a control surface, which we deflect, the effective camber changes. The pressure distribution has been changed, and the lift force has been increased. The direction of this resultant change of lift force depends on which way we move the control surface. Deflecting downwards increases lift and the wing lifts, while deflecting upwards decreases the effective angle of attack, reduces lift, and the wing becomes downgoing. When the pilot operates his control, one aileron moves up and the other down. The foreground wing will become downgoing and the other one upgoing. When airflow is introduced, the aircraft rolls in the direction of the downgoing wing. When the control is operated in the opposite way, the foreground wing is upgoing and the other downgoing. Once more, the aircraft rolls in the direction of the downgoing wing. So long as the ailerons are deflected, the aircraft continues to roll.
So ailerons affect roll. Now the rudder. The axis is the normal or directional. The primary effect of the rudder is to yaw.
If we move the rudder to the left, the aircraft moves to the left. The same to the right. In other words, the aircraft yaws in the same direction that the rudder moves. This would eventually cause the aircraft to turn, but it would also cause it to move sideways in the opposite direction. And so it's really more effective to turn by banking, using ailerons and very little rudder. We use the rudder during landings and takeoff to keep the aircraft straight. During a spin, to reduce the rate of roll sufficiently to pull out of the spin, or to correct yawing caused by asymmetric power when an engine fails on multi-engined aircraft.
The rudder affects yawing. Now, the third of our primary controls, the elevators. Lateral axis, affecting pitch.
Upward deflection of the elevators causes a downwards force on the tailplane, an increased angle of attack. And if speed is maintained or increased, the aircraft will rise. Once onto a steady climb flight path, the elevators are returned to neutral. If you don't, the aircraft continues up into a loop.
We're in a dive. The elevators are brought upwards, bringing a downward force on the tail and a resultant increase in lift.
Once in a steady horizontal flight, the elevators are returned to neutral.
If we reduce speed and raise the elevators, the aircraft flies straight and level.
Because the elevators have increased the angle of attack, balancing the loss of lift due to decreased speed. Lift force, therefore, remains the same. At higher speeds, the sort of trailing edge controls we've seen may or may not be very effective. On aircraft like this, it's more effective to move the whole of the tail. On such aircraft, the whole tailplane moves about a hinged point. The variable incidence tailplane may have one or two uses. As the main flying control in pitching, used with elevators which have a trimming effect, or as a slab tailplane without any elevators. It might also be used as a means of trimming. The elevators remain the main controls in pitching.